going to look at how we can use graphs to misrepresent data. And lots of agencies do this often. Governments will do this, businesses will do this. All kinds of different organizations will give you a graph to make it appear like something's happening when maybe that's not really the case. So let's just see how we might do this with some math marks, how we might misrepresent this data. So let's just say your math mark in term 1 was 82%, in term 2 it was 85%, and in term 3 it was 87%. So we can see by looking at the data that yes, the mark for this particular student has improved. Went from 82% in term 1 to 87% in term 3, but not really all that much. So let's do two graphs. We'll do one graph that would show this as it should without being misrepresented, and then I'll show you how we can use a graph to misrepresent some data. So let me just get some grid lines on here. And then we will draw a graph. So we'll make this 10%, 20, 30, 40, 50, 60, 70, 80, 90, and 100. So I would label this percent. My title would be Math Marks. And down here I'm going to go term 1. I'll leave a bit of space and do term 2 here and term 3 here. So in term 1 he was at 82%, which would be about right here in my graph. 80 is here, 90 is here, so 82 would be about there. Term 2, 85 would be right in the middle. And in term 3 it would be 87, which might be about there. And then I'm going to do a line graph because this is over time. First term, second term, third term. And it would look something like this. So showing the graph like this, does it look like his math marks improved very much? Not really. It's gradually going up here, but it's still fairly flat. So that's really what's happening to this person's math marks. They're fairly flat, a slight improvement. Well, let's take a look at how we can do something to this graph to make it look like the mark has really gone up. So I'm just going to do a new one here. So same thing, math marks. And down here we'll do term 1, term 2, and term 3. So right here is 0%, but what I'm going to do is instead of going 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, I'm going to chop this axis off. So I'm going to do a little squiggle line here to indicate that I don't really have any information down here. My information kind of starts around 80, and then 81, 82, 83, 84. So this is my percent here. So since all of my information is in the 80s, what I could do, and it's okay to do this as long as you do a little squiggle line here to indicate that there's more information down here. We're not going to show anything there because their information starts at 80. And now I'm going to plot these 3 points. So the first one was 82, and then 85, and then 87. So 82 dot would go right here, then an 85 dot right here, and then an 87 dot right here. And now when I connect my dots, it looks like this. So when I show this graph, if you were to take a look at this one, your first impression is, wow, these marks have really improved. Look at how steep this line is. But it's not until you actually look closely at the scale here that, you know what, really it's just 82 to 85 to 87. So yes, it's improved, but really not as much as it appears in the graph. So this would be an example of a line graph that is misrepresenting the data. If someone who doesn't know much about graphs just quickly looks at the picture, it looks like there's been a significant improvement here in the situation. So we can, one way that graphs get misrepresented is when people take this axis and kind of chunk part of it off by doing this little squiggle line here and then start the axis again at a certain value. It's important to know that once you start your axis at 80, if I go up by 1 every square here, you must continue to go up by 1. So I can't just go 80 and then 81 and then 85 and then 87 and then 96. Once I start going up by a certain number each time, I have to continue to go up by the same amount. I can only do this little chop here, chop the axis off initially. Once I start going up, we can't chop the axis off anymore. So there's how we can misrepresent using a line graph. So let's say here we have two stores that have some profits. So let's say store A, we know over the year made $10 million, and store B made a profit of $8 million. And let's say we're store A and we want to show that we have made a whole lot more money than store B. We could do things like this another way. So let's go 1 million, 2 million, 3 million, 4 million, 5 million. So instead of chopping this axis off, which we could do as well, and then just start at 8 and go 8, 9, 10, we'll do millions of dollars on this axis. We need a title, so we'll just say profit. And then this would be a good one to do bar graphs because we have two different categories down here. So let's do store A here. And we'll do store B over here. And so if we were doing a bar graph, if we did it like this for store B, so store B was 8 million, so I'm going up to 8 million. And then I could also do something like this. I could make the bar for store A a whole lot bigger, make it twice as big. Twice as wide, rather. So it's still accurately showing the height. Store B has a height of 8 million, and store A has a height of 10 million, but I've made the width of store A a whole lot bigger. I could do other things. I could shade it darker, make it stand out more. So now when you quickly look at this, you're like, wow, look at store A. It's such a big bar compared to store B. That's misleading. Store A looks like its profits are so much more bigger than store B. When really, there's only 2 million more in store A than store B. So one way is to make the width of the bar wider than the width of the other bar so that it appears like this is such a bigger bar. I'll show you one other way that we can make things misleading. So here's how we can make some pictographs look misleading. So if we look at this one here, this graph, it's showing that the United States is producing more trash. So in 1960, there's a garbage can that goes up to 80 million tons. So there's 80 million tons of garbage produced in 1960. In 1980, there was 160 million tons. So the amount of garbage in 1980 compared to 1960 is twice as much. The problem is that this garbage can here is actually not twice as big as this one. It's 4 times bigger, because instead of going, let's get a different color pen there. Let's go with red. Instead of keeping things the same, so imagine we had a bar graph here. instead of keeping this garbage can the same width as this one and just making the height twice as big, they've actually extended the width twice as much as well. So this is a misleading graph because this bar is twice as wide as this one, and it's also twice as tall. So misleading. It looks like, when you look at this garbage can right here, that this garbage can is about 4 times bigger than that one, when really it should only be about twice as big. Here's another pictograph that's misleading. If I quickly look at this, it looks like, wow, hot dogs are the biggest seller. Look at how long this string is here, whereas French fries is the least. But when you actually count these, 10 items, each of these pictures represent 10 items. So this would be 10, 20, 30, 40. There's 50 fries sold, 10, 20, 30, 40 hamburgers sold, and 30 hot dogs sold. The problem is the size of each of these images was different. And so the illusion, or the misrepresentation, is it looks like hot dogs are the most common thing sold, when really they should be the shortest because there's only 30 of those, and the French fry should be the longest bar. So these are ways that we can misrepresent data, and we want to be sure that we understand the graph so that if someone does show us a graph that is misleading, we can look at it and say, this is a misleading graph. This is actually what the information is showing.